Yesterday we started talking about vectors and just how they work and some of our basic, how we represent them in the plane, how we add them. So we're going to do a little bit more work with just some of the basics of vectors. So our first definition is if we have a vector with a magnitude of 1 in the same direction as another vector v, we call it a unit vector. So anything with a magnitude of 1 is called a unit vector. If you want this unit vector to go in the same direction as another vector, what you do is you take your vector v that you're given, and you divide that by the magnitude of v. So that's going to give you a unit vector, so a vector that's only length 1, but it goes in the same direction. So here's how this works. We want to find a unit vector in the direction of the vector 6, negative 1. I'm going to draw this and hopefully you can see it a little bit better. So if we have a vector, 1, 2, 3, 4, 5, 6, negative 1, okay, so here's our vector v. Okay, I want a unit vector, so I want a vector u that goes in the same direction as this but only has a length of 1. That's what we're looking for. So to find that u, we take our vector v and we divide it by the magnitude of v. Remember, magnitude is just distance formula, how long it is. Okay, so we can take 6 squared plus negative 1 squared. So we get 6 negative 1 over the square root of 37. And we're going to divide both of those by the square root of 37. So 6 over root 37 and negative 1 over root 37. Generally, we don't have to rationalize or anything. You can if you want, but it's not really necessary. Then the second part of this is to verify that the result actually has a magnitude of 1. Okay? So we need to show that this vector u that we just created actually has a magnitude of 1. So to do that, we need to use the distance formula and show that the magnitude of u is indeed 1. So here we go. It's going to be the square root of 6 over root 37 squared plus negative 1 over the square root of 37 squared. So that will be the square root, 6 over root 37. If we square that, that's going to be 36 over 37. Negative 1 squared is 1, root 37 squared is 37. So we get 36 37ths plus 1 37th. That's 37 37ths, otherwise known as 1, and the square root of 1 is indeed 1. So we have verified that this is a unit vector. Okay, let's just do one more to kind of practice that. So we want to find a unit vector in the direction of negative 2, 5. So again, we have negative 2, 1, 2, 3, 4, 5. Okay, this is our vector v. We want to create a unit vector u that goes the same direction, but it's only 1 unit long. So u is going to be our vector v over the magnitude of v, which is just the distance formula. Remember, since vector v starts with the origin, I mean, technically you can do negative 2 minus 0 squared plus 5 minus 0 squared. Not necessary since there's zeros. Okay, so we get negative 2, 5 over, let's see, that's 4 plus, so square root of 29, 4 plus 25. So our new vector is going to be negative 2 over root 29 and 5 over root 29. So that's what this little green vector is over here. Then we have to verify that this indeed has a magnitude of 1, so we're going to find the magnitude of u, again, just the distance formula. Now, technically it's negative 2 over root 29 minus 0. We don't need the minus 0. And then 5 over root 29, again, minus 0, but we don't need that. Okay, so negative 2 over root 29, if we square top and bottom, we get 4/29. On our second fraction, if we square top and bottom, we get 25/29. So this is 29/29, which is 1, and the square root of 1 is 1. So it is indeed a unit vector. You're going to have some homework problems like this. That's what it means to verify that you actually have to plug it in and show that it works. So just make sure you're doing that. We will talk about directional angles in the next video.